Assalamualaikum warahmatullahi wabarakatuh, and hi, we are from Faculty of Mechanical Engineering, VMM 3531 from section 03. Is going to present about the experiment of heat pump. My name is AMIRUL HAZIQ bin ZAINUDIN, metric ID MA18122, and our group consists of 6 students: Muhammad RAIS bin MOIDEEN, Muhammad HASBULLAH bin Abu Bakar, Muhammad Syuaib bin Suhaimi, KOGULAN anak lelaki MANIAM, AMIRUL HAZIQ bin ZAINUDIN, and one Muhammad ALIFF bin one AZLI. So I'm going to start the presentation with the introduction. A heat pump is a system that transfers heat from a cooler to a higher temperature area. It is the opposite of natural heat movement, which is from warmer to cooler area. And popular system types include air source heat pumps, ground source heat pumps, water source heat pumps, and exhaust air heat pumps. Heat pumps are also extensively employed in district heating systems. A coefficient of performance, which is COP, or seasonal coefficient of performance SCOP, is used to calculate the efficiency of a heat pump. A heat pump with a higher number is more powerful and energy efficient. And this is the movement of the heat pump, and on the right side is the examples of heat pumps. And the objective of our experiment is first to determine the coefficient of performance for a vapor compression heat pump system, and next is to determine the rate of heat transfer of heat pump. So I'm going to pass the presentation to the second presenter to present about the literature review. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad RAIS bin MOIDEEN, metric number MA18106. So now I will continue about literature review on this heat pump experiment. So there are 4 main components in this process. So let me explain the process 1 until 2, where we call this as a compression process. The refrigerants enter the compressor as saturated vapor in an ideal vapor compression refrigeration cycle and is compressed isothermally to the condenser pressure. So during the isentropic compression process, the temperature of the refrigerant rises to the above the temperature of the surrounding medium. So next is the process 2 until 3, where we call it as a condensation process. As a result of the heat rejection to the surrounding just now, the refrigerants enter the condenser as superheated vapor at state 2 and exist at a saturated liquid at state 3. So at this point, the temperature of the refrigerant is still higher than the temperature of the surroundings. So next, process 3 until 4, we call a throttling process. By passing it through an expansion valve or capillary tube, the saturated liquid refrigerant in state 3 is throttled to the evaporated pressure. During this process, the temperature of the refrigerant falls below that of the refrigerated space. So the last process, process 4 until 1, we call as evaporation process. At state 4, the refrigerant enters the evaporator as a low quality saturated mixture and evaporates completely by absorbing the heat from refrigerated space. The refrigerant exits the evaporator as saturated vapor and returns to the compressor to complete the cycle. So these are the diagram for TS and PH. So next is the simple formula for the mechanical pump performance coefficient, where COP equals to Q over W, Q equals to MCP delta T. So where Q is the heat removed, W is the power consumed by the compressor of unit time, and M is the mass of water in heating and cooling, and delta T is the change of temperature between the initial and final temperature of water in unit time in Kelvin. So Cp is the specific heat of water in kilojoule per kg times Kelvin. So that's all for my literature review. Next, I would like to my friend Muhammad Alif will continue. That's all from me. Thank you very much.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Alif, MA18115. Today I will continue with lab equipment. Over here you can see lab equipment that we use. Number 1 is expansion valve. Number 2 is refrigerant flow transmitter. Number 3, side glass. Number 4, flow transmitter. Number 5, condenser. Number 6, evaporator. Number 7, low pressure cut-off valve. Number 8, high pressure cut-off valve. Number 9, filter dryer. And number 10 is compressor. Okay, next is about experimental procedure. First, the ball valve is turned on for water supply. Next, the equipment ball valve opening is regulated with our setting value of fully open. Next, the main switch is on. Number 4, water pump is switched on. Next, R134A is switched on. Next, at flow selector section, selector 2 is chosen for the calculation of water flow rate, and selector 1 is chosen for refrigerant flow rate. At temperature indicator selection, temperature was selected accordingly to for temperature data. Next, at press indicator selector section, pressure was selected accordingly for pressure data. Number 9, a few seconds is waited before reading the values. Next, value, flow indicator, temperature indicator, press indicator, and power indicator value is noted. Next, the experiment is repeated with 60% open valve, 20% open valve, and fully closed valve. And number 12 is formula to get the water and refrigerant flow rate in LPM. The precaution is beware of hot surface. Make sure the heater power supply is first switched off before replacing the heater insert. Next, do not touch the fan while conducting the experiment. Next, be careful when connecting any socket to the power source. Lastly, the parallax error should be avoided while taking the reading. I think that's all from me. Thank you.
I'm KOGULAN MANIAM MA18098. I would like to continue the presentation on the results department. Okay, so there the results here we can see the condenser temperature outlet and the condenser temperature inlet, and then the water flow rate, the water mass flow rate, the compressor power consumption, the condenser heat load, and the COP heat pump that has been calculated. So here the second table here shows the flow rate of the valve, where there's 4 type of valve positions, which is fully open. There's a 68.3 of flow rate, and then 60% open, flow rate of 40.98, and then valve which is 20% open, and the flow rate is 13.66%, and the fully closed valve has flow rate of 0.9%. So the calculation, here's the calculation for the volume, flow rate for the fully opened valve, how the calculation has been calculated. So water flow is 10 liter per minute, so must find the actual flow rate. Then the water density is referred to the table, and the water mass flow rate for fully open. Here is the flow rate calculation. Then the next part is counting the H specific, which is the interpolation method. So here the results for the H1 is 262.54 kilojoule per kilogram, H2, H3, and H4. Now based on the calculations and the tables and the data given, this is the chart of coefficient of pump versus the water flow rate. So that's all from me. I would like to let my colleague to speak. Thank you.
Assalamualaikum. My name is Muhammad bin Suhaimi, metric number M818113. I would like to continue on the discussion. Number 2, what is the factor that will influence the coefficient of performance, or how? So the main factor that influences coefficient of performance is the operating condition, which is absolute temperature and relative temperature between sink and system. In this experiment, the air temperature difference between inside that affects the coefficient of performance. So the coefficient of performance, which is the ratio of the cooling load of the culture room to the electricity consumption of the air conditioner or air conditioners or electrical energy used efficiently of air conditioner, is influenced by several factors. So from the experiment, based on the coefficient of performance graph, it showed that the office of the heat pump system is increasing from fully open to the fully closed valve respectively. For fully open valve, the value of flow rate is the highest, which is 5. For 60% open valve, is the value is 4.48223, and for 20% open valve, the value is 4.5091, and for the fully closed valve, the flow rate value is 4.3684, which is the least value. So when the valve is fully open, there will be more water flow through the pipe, so the result occur as good heat exchanger in the condenser, which means that situation indicates the highest coefficient of performance of the heat pump. Next, from the experiment, list down the errors that might influence the results. First, a refrigerant condenser with a variety of abrupt bends and pipe bore small enough to allow high rate flow might create excessive refrigerant pressure decrease due to viscous friction. And the collection may contain significant mistake if the condensation technique is expected to occur at constant pressure. Such constraints should be carefully considered in the design of instructional instruments in order to offer accurate findings. A pressure drop is produced by viscous friction within the section line. Aside from the fact that the refrigerant is the vapor state, which results in minimal resistance losses. So the suction line is extremely short in the length and has a pressure drop. In typical operating setting, the refrigerant leaving the evaporator might be below near the temperature, resulting in a heat gain from the surrounding to extend superheat. So the suction line is sufficiently insulated to give the impression that this does not happen.
Assalamualaikum. My name is Muhammad HASBULLAH and my ID is MA126. So today I'm going to continue to present about the discussion, which is the question number 4 is about how to improve the accuracy of the experiment's results. So this experiment result accuracy can be improved by taking out each conceivable irregular error and the methodical mistake. The temperature in the analysis of to be estimated on different occasion and take its mean worth to diminish the level of error. Then the instruments utilized should be sent for the accuracy testing to result its arrangement in case mistake is found. The investigation ought to be finished with a consistent wind current in the room. So last but not least is about the conclusion. So what we can conclude is the target of the heat pump analysis accomplished by making examination between the real and ideal vapor pressure refrigeration cycle and deciding the coefficient of performance, which is COP, utilizing distinctive valve opening. The outcome pass on the connection between the state of the valve and the proficiency of the evaporator and the condenser. It likewise shows that the productivity is marginally expanded when the valve change from the completely open to 60% open. However, although together drop as the valve is at 20% open. This outcome is additionally talk about the conversation part with extra information. When the valve is shutting, the flow rate and the mass flow rate gradually diminishing. As approaching liquid becomes lesser from the chart of COP against water flow rate, it shows that COP of the heat pump will be somewhat expanded with the additional on water flow rate boundaries. This is because of the condenser heat expulsion being affected by the volume flow rate, while the coefficient of execution impacted by the condenser heat evacuation. I think they're all from us. Thank you.